So we're going to start with chapter 9, and chapter 9 is solving quadratic equations. That is different than chapter 8 because chapter 8 was all quadratic expressions, and we would factor them with a GCF, and then factor by guess and check, and factor by grouping. So here the difference is all of these are equations, so they all have an equal sign. And you're going to learn several methods on how to solve, and then eventually kind of strategize about which method is best for what type of problems. So the first method we're going to go through is called square root method. You guys have actually seen this before in trimester 1, so we're just going to review with these first 8 problems to kind of refresh your memory. So notice none of these have the b term. There's not a just x. So if there's only an x squared and not an x term, you can use the square root method. And all you've got to do is get the x squared alone. And then to undo the x squared, it's a square root. So on number 1, x squared equals 25. The x squared is alone. So to get rid of it, or to get rid of the squared, use square root both sides. Square root of x squared is just x. Square root of 25, you've got to remember, is not just 5. It's positive and negative 5. So there's actually 2 answers there, not just one. If you plugged either one of those back in, we checked it, positive 5 squared is 25, and negative 5 squared is also positive 25. So we can kind of mentally math or use mental math to check that. For 2, very similar to number 1, but the x squared is not alone. So before I can square root both sides, I have to get x squared alone. So we're going to divide both sides by 3, which gives me x squared equals 9. Now that the x squared is alone, square root both sides, and x equals positive and negative 3. Okay, number 3 is, again, very similar. We're just going to add one more step into it. So again, we've got to move everything away from the x squared. So the first thing we do is we add 5 to both sides. So it gives me 2x squared equals 98. Now divide by 2, and x squared equals 49. Square root both sides, and x equals positive and negative 7. That is our answer. Okay, 4, again, very similar to this. So add 16 to both sides. We're adding this 16. Gives me 4x squared equals 0. I still need to divide by 4 on both sides before taking the square root. So divide by 4, and 0 divided by 4 is still 0. And then square root it. What's slightly different with this problem is the square root of 0, we don't write positive 0 and negative 0. It's just 0. So this particular problem only has one solution, where problems 1, 2, and 3 had 2 solutions because they had the positive number and the negative. Okay, starting on 5, it looks like one of the other ones that we've done, but here in a minute you'll see how it's slightly different. So if we add 7 to both sides, I get 135. Divide both sides by 3. And you can always use a calculator if you wanted to. I mean, you guys have your phones, or if you have a calculator at your house, or you can also use Desmos. So you can have that window up and use it just for a calculator. There's no problem with you guys using calculators. We get 45. Now, when I go to square root both sides, I've got a problem of 45 is not a perfect square, meaning I can't take the square root of it and get a whole number. So what's going to happen is I need to break down that square root. I need to find the biggest perfect square that goes into 45. And again, you guys did this first trimester, but it has been a little bit. So at the top of this paper, I'm going to write down a list of the perfect squares. So 1 squared is 1, but that's not very helpful for breaking down 45 because it's just going to leave it 1 and 45. So the first one that's helpful is 2 squared, which is 4. Then 3 squared is 9. 16, because that's 4 squared. 5 squared is 25. And so on. 36, 49, 7, 8 is 64, 9 is is 81, 10 is 100, and this list, could keep going on for a very long time. So I need to find which one of those numbers goes into 45. So you start with the number closest to 45. 49 is too big, so that doesn't work. So next is 36. 36 doesn't go into 45 evenly. Next in line would have been 25. 25 doesn't go in evenly. Next is 16. 16 doesn't go in evenly. So now we're to 9, and 9 does go into 45 evenly. So we're going to start by saying x equals plus or minus, because we don't want to forget that. Now I'm going to break up the square root of 45 into the square root of 9, because that's my perfect square, times the square root of 5, because 9 times 5 is 45. And now I can simplify this answer as plus and minus. Well, the square root of 9 is 3. I can't take the square root of 5, so it stays underneath the square root sign. Sorry, that's a 5. It's not a very good 5, but that's a 5. So hopefully for some of you guys, you can look at this and go, oh, I do kind of remember this from first trimester, because it is a skill that you're going to be using throughout this entire chapter. So let's do one more real similar to that, and that's number 6. So for number 6, we need to add 6 to both sides. So negative 2x squared equals negative 64. Divide both sides by negative 2. Now I turn to positive 32. Square root. And again, 32 is not a perfect square. So I look at my list at the top of the screen and I say, well, what perfect square goes into 32 evenly? 36 was too big, so 25 does not go in there, but 16 does. So break this into square root of 16 times the square root of 2, because 16 times 2 is 32. That would leave my final answer as plus or minus 4 radical 2. So that's how you deal with them if they're not perfect squares when you take the square root. What I want you to do now is I want you to pause the video and I want you to go through 7 and 8. Try them on your own. Please don't just watch the video straight through. Try them on your own and let's see if we get them right. So hopefully you paused it. You actually did try the 2 of these. 7 should have gone pretty well. 8, something a little bit different happened on 8. So I want to see if you guys actually caught that or not. On 7, you would have added 50 to both sides. Gotten 4x squared equals 300. Divide it by 4. X squared equals 75. Take the square root. Next equals plus or minus. 75 is not a perfect square, but 25 goes in there 3 times. So final answer, x equals plus or minus 5 radical 3. And that would be our 2 answers. Remember that that's 2 answers. We have positive 5 radical 3 and negative 5 radical 3. Okay, 8. So 8's the one where I said it goes off pretty normally, but then something at the end happens a little bit different. So if we add 56, we end up with negative 81. Divide that by 3. X squared equals negative 27. And then when we go to square root this, some of us are going to jump to it and say, ooh, 27, that's 9 times 3, and go on from there. But we have to stop and go, wait, that's the square root of a negative number. I can't do that, right? There's not 2 numbers or a number that I could take times itself and get a negative. So this is not possible. And how we write the solution to this one is that there are no real solutions. And that word real is a big deal. In Algebra 1, we don't play around with what are called imaginary numbers. So we need to emphasize no real solutions. There's not a number that I can square to get negative 27. Okay, so hopefully you did well on those two. If you did have any mistakes, make sure you are kind of looking at it and go, well, what did I do? Was it just something little or was it something bigger? And make sure we are learning from those mistakes. So now we're going to move on to another method, and we're going to start with a logic question. If a times b equals 0, what is true about the value of a or b? So kind of think about it for just a second. A times b equals 0. What has to be true about a or b? Well, if a product comes out to be 0, either, oops, turn my pen back on, either a is going to equal 0, or maybe b is equal to 0, or they both are. That's a possibility, right? Regardless, at least one of those has to be 0 in order for that to happen. First, multiply any two numbers and get 0. One or both of the numbers has to be 0. And this is called the zero product property. So if you look down at problems 9 through 11, you'll see where this comes into play. So 9, this is essentially the same as the logic question, where the 2x minus 3 would be your A, and x plus 5 would be your B. So if A times B is 0, well, then I know that 2x minus 3 could equal 0, or x plus 5 could equal 0. And now I solve. You just got two little Algebra 1 problems. So add your 3 to this one, divide by 2, and we get 3 over 2 is one of my answers. And on the other half of the problem, subtract 5 and x equals -5. All right, that's a 5. Now, there's two answers to this one, just like there were two answers to most of the problems with the square root method. Difference being is 3/2 and -5 are not opposites of one another. We don't have that plus and minus sign. Okay, so let's try this again. Number 10. So this is essentially the same thing. A times B. So if those multiply together equals 0, then 2x plus 7 could equal 0, or 2x minus 7 could equal 0. Equal. There we go. Solve each of these separately. So 2x could equal -7 by 2. We get -7 over 2. Sorry for coughing so much. I've got a cold. It's not coronavirus. Divide by 2. And x equals 7 over 2. So those are my two answers for number 10. 11. So you guys have seen 11 before. You could technically use square root method on it. We're going to talk more about that at another lesson. But we know that x minus 8 squared is the same thing as saying it's x minus 8 times itself. So now we have that a times b. Now the fact that these are the same thing, you don't have to show it twice. You can just say, hey, these match. So x minus 8 must equal 0. Add 8 to both sides. X equals 8. So this one only has one solution, just like how in square root method, sometimes you do get one solution. It's totally fine. All right. So those are all set up in factor form, right? You guys just got done doing a ton of factoring. It should have looked a little familiar to you. So now, if we're going to solve by factoring, so the a times b equals 0, the zero product property. Once you factor it, then you're good. The biggest component there is every equation has to be equal to 0. That's how the zero product property works, is you have to take something times something else equals 0. It tells you no matter what I do, one of those things has to equal 0. So in 12, notice we can't do the square root method because we have that middle b term. So we're going to try to factor it. So to review from before break. And we look at this, we say, okay, well, it's a 1x squared. So I know this is an x and an x. And I can kind of use my shortcut too. Two numbers that multiply to be 15 and add to be 8. Well, that's 5 and 3. Plus 5 plus 3. Now it's a problem like we've just seen. This is A, this is B. Zero product property says at least one of those has to equal 0. So set each one equal to 0. We get negative 5 and negative 3. And that's it. 13 is the same idea. So take a minute, pause the video, see if you can factor it, and then turn this back on and check if you did it correctly. So pause it now. Okay, and hopefully you've had a chance to do that. So if I factor this, this becomes m plus 2 times m. Ooh, that's an m with some flair equals 0. So m plus 2 could equal 0, or m minus 7 could equal 0. M equals negative 2, and m equals 7. And voila. Okay, if you didn't pause it for 13, pause it for 14. Try it on your own. If you don't try it on your own, you're not doing yourself any good. So factor p squared plus p minus 20, have that equal to 0, and solve. Okay, and again, hopefully you actually did try it on your own. This is p plus 5 and p minus 4. Set these equal to 0. So I get negative 5 and positive 4. Okay. So I'm going to switch color pens because we're going to change to a slightly different topic is for 15. I'm still going to factor, right? I still have this middle term that says I can't use the square root method. But the difference is 2a squared. I can't use the shortcut for factoring, so I need to do a little bit of guessing and checking. So 2a squared only has two factors, 2a and a. Now 18 has a lot of factors. I use 18 and 1, 9 and 2, 6 and 3. So I need to guess one of those and then check it. So if I guess, let's try it on 9 and 2. And they'd multiply to be a positive, but add to be a negative. So let's make them both negative. So check it. If I multiply this out, 2a squared minus 4a minus 9a, that's 9, plus 18. I've got a problem because if I combine those, negative 4 and negative 9, it's not going to give me negative 15. So I say, okay, well, that one didn't work. So I could try switching the 9 and 2 and try it there, or I can try a different factor. So if I did 3 and 6, and let's see, I can put 3 here and the 6 here. Let's check it. If I multiply it out, 2a squared minus 12a minus 3a plus 18. Double check these middle ones. Negative 12 minus 3 is negative 15. So I do have the correct factored form. So I'm going to get rid of my check just because I need the space. And you can always do that off to the side if you were taking a test or doing your homework. So now that I know that that is the correct factored form, set it equal to 0. And solve each side. So over here, I'm going to add 3, divide by 2, 3 over 2. And over here, add the 6. There's my two answers. Okay, so 2 more. What's different with these two, if you look at them, how are they different from the previous 4 that we've done? Hopefully you've noticed that they're not equal to 0. If they're not equal to 0, we need to make that happen before trying to solve every single time. So let's see, I'm going to change this one to blue since we are on a different topic again. So on 16, I need to subtract the 18 to both sides, and when I rewrite it, I want it in standard form. So this would be minus 18 equal to 0. So we have that piece of it done. Now it's ready to try to factor. For guessing and checking, this one's a little trickier because my x's could be 2x and 2x or 4x and 1x. So let's try 2x and 2x. Just because, I don't know, that's one I picked. No rhyme or reason, just picked it. Then for 18, again, I'm looking at 18 and 1, 9 and 2, 3 and 6. So, I don't know, let's go with 3 and 6 again. They need to multiply to be a negative. So I know at least one of them has to be positive and the other be a negative. So let's try it. If I multiply this out, 4x squared minus 12x plus 6x minus 18. See, negative 12 plus 6 is negative 6. That is not negative 21. So I do not have the right numbers. Switching the 6 and 3 isn't going to do me any good here since both of these begin with 2's. So I can try maybe 9 and 2. 9 times 2 is 18. Let's try it. 4x squared minus 4x plus 18x minus 18. If I check here, that gives me a positive 14. So nowhere in the ballpark. Even if they were switched signs, so even if this was positive and this was negative, I'm at negative 14. Regardless, that's still not 21. So, and I don't think it's going to be 18 and 1 either, because 21, if I multiply 18 by 2, I'm already at 36. So I'm looking pretty big. So, which means I'm going to go all the way back, trying. Let's ditch the 2x and 2x. Let's try 4x and x. And again, let's try 6 and 3. I'm going to go 3 here, and I'm going to go 6 here. And we'll go positive, negative. So multiply this out. 4x squared minus 24x plus 3x minus 18. And when I go to combine my terms, I get my negative 21x. So that means I finally have it factored, right? And we know from last chapter, guessing and checking can take some time, and it's fine. It's not a big deal, right? It's good that we find the right ones. Because now it's easy from here. Set each of these equal to 0. So on this side, add the 3. Divide by 4, 3/4. And on this side, add 6. And we're done. Those are my 2 answers. Okay, I want you to pause the video and I want you to try 17. You got to get it equal to 0. Make sure you write it in standard form, then factor it, and then solve it. Okay, so pause the video now and try it on your own. Hopefully you actually pause it. So we're going to subtract 14x from both sides. So that is x squared minus the 14x. And I'm writing it here because I need to write my equation in standard form. That's going to help me factor it. So I got to factor this. X and x. What 2 numbers multiply to be 49 and add to be negative 14? That's a negative 7 and a negative 7. If I wanted to, I could write it as x minus 7 squared and then use the square root method like you did in problem 11. Or I can just look at this and say, hey, it's the same thing twice. X minus 7's got to equal 0. So x is just 7. And that'll be a little faster for you. So practice these on the homework. Make sure you are showing your work. We're expecting you to show work on the homework being done on your own paper. And if you need help, you need to join your teacher's conference so that you can ask them the questions that you need and clear up anything that you're stuck on.